For our master's project, we decided to make a robotic device to correct for the errors associated with human movement in precision applications. We were inspired by a handheld milling device, where the user would trace the design roughly by hand and the cutting head would move to correct for the error in the user's position. This allows for a much smaller system, where the user does the majority of the actuation and the system corrects for the error. This is limited to 2D movements, but we wanted to bring it into the third dimension, to make the system more compatible with a wider variety of tools and potential applications. Our device can actuate in 3 dimensions and does so faster than a human arm. We used this ability to smooth small, quick motions from the human operator, effectively making the tool glide in front of the handle. However, this actuation can be used to add precision to the operator's movements, such as a cutting tool, which is restrained to a virtual guided path. This will be great for hobbyists and small businesses that require precision tooling but can't justify buying large specialist equipment. The main challenges of this project were the actuation and sensing. The system must be able to track the movement of your hand and be able to actuate and counter it. For the actuation, we decided to use a delta configuration, which is commonly used in industry for fast linear motion. We saw delta arms as being the most practical to miniaturize due to its simplicity, keeping the handheld device small and light. This is also why we used servos to operate the delta arm, as they have gear reduction and rotational sensing built in, making the tool end as strong and accurate as possible. The sensing was more of a technical challenge than we expected. We used an optical method to track the position, which consisted of 2 high-speed infrared cameras looking for illuminated targets on the handheld device. By having 2 cameras tracking these points, you can calculate the 3D position and orientation of the tool. We also built in a gyroscope and accelerometer to sense finer movements in the user's motion. After some filtering and processing, the system knows exactly how to move the tool to stabilize the user's hand motion. The system was made entirely from off-the-shelf components and 3D printed parts. For example, the main processor is an Arduino and the tracking cameras are just USB webcams. Since the hardware is so universal, future upgrades and features only require a software update. This allows for a wide range of specialist software for applications in many fields, such as medical, manufacturing, and military. Surgeons could have a scalpel which actively avoids critical areas, and hobbyists could have a tool that automatically places small components onto a circuit board, making surface mount prototyping easier and more convenient. With precise tracking and actuation, the system can add more functionality to a host of tools and applications. Really, the possibilities are endless.